This is episode 1 of the Raised Beaches podcast. So, in today's deep dive, I thought it would be best to explain what is a raised beach. Currently, it's the middle of the summer in the northern hemisphere, and if you're like me, you want to hit the beach. Of course, what is a beach? Of course, you really think about it. It's something that's at the place where the ocean meets the land. And yes, a beach, by the best geological definition, is an unconsolidated sediment that is deposited by the action of waves and currents. Of course, when I'm talking in this episode about beaches, I'm talking about beaches at the ocean. I'm not talking about lakes. Of course, beaches can form at the coasts of lakes, and I will get into that in another episode, I'm sure. So the most strict definition of a beach, though, is where is the highest elevation reached by storm waves and the low tide mark. Because of this relationship of a beach to the position of sea level, it is often used as an indicator of past sea level position. So this is a very famous thing, and I will talk about this more later in this deep dive. Raised beaches were first discussed in the early 1800s, and it was one of the first pieces of evidence to show that the Earth's surface was not static and it was not unchanging. So the early reports on raised beaches influenced the then nascent scientific discipline of geology. But, we know about beaches that are at the coast now. What is a raised beach? So, raised beach is a landform that is above present day sea level, and it shows that in the past, in a relative sense, sea level position was higher than present. And that's an important thing to note, is it's what is known as relative sea level. So sea level is actually not something that is the same in time and space. And I'll discuss that more in episode 2. But the important thing to know is that in a relative sense, a raised beach is evidence that sea level in that location was higher than present. And these raised beaches, you can find evidence of a past connection with the ocean. Often you'll find shells in them that have a marine origin, and they will have a sediment, a characteristic in the sediments that demonstrates that it was deposited through wave action. One of the places where you can easily see raised beaches is around Hudson Bay in central Canada. And one of the great tools for a geomorphologist or a geologist is Google Earth. So you can actually go and zoom in and look at these for yourself. If you zoom into Hudson Bay, especially around the Manitoba coast, you can clearly see these linear features that stretch for kilometers and can be quite a ways from the modern coastline. If you go on the ground, it's clear to see why these beaches are visible from the satellite imagery in Google Earth. It's because in northern Canada, it's a tundra landscape, so things don't really grow that quickly. So on the surfaces of these raised beaches, there's nothing growing on them. They're gray and lifeless, and they really stick out in the topography. So it's very clear to see that these beaches are there if you go there. There are many ways in which raised beaches can form. There's lots of different geophysical and geological processes that go behind that. The first is that Raised beaches existed because in the past, sea level was higher. So global sea level is controlled by the size of ice sheets on the surface of the Earth. Right now, there are ice sheets in Greenland and Antarctica, but in the past, North America and Europe were also covered in ice sheets. And in certain very isolated times in the past 3 million years ago, the Greenland ice sheets and Antarctic ice sheets were actually smaller than they are now. And as a result, the global average sea level was higher. And the last time that happened was in a period known as the last interglacial, which was about 125,000 years ago or so. And at that time, sea level was definitely higher. Global average sea level is definitely higher than present because all over the world you find raised beaches and other similar indicators of past high sea level. In 2015, Dutton et al. Came with an estimate that global average sea level was 6 to 9 meters higher than present. But a more recent estimate by Dyer et al. Brought that down to closer to 3 to 5 meters or so. And anyway, the thing is that you will find raised beaches in many places around the world because of the global average sea level being higher than it is now. The second and third reason you'll have raised beaches are related to a process which is known as glacial isostatic adjustment. And this is the bulk of what I research personally, and definitely I hope in a future episode I will have a deeper dive into this subject. But for now, the important thing is that in places that were covered by ice sheets and those ice sheets have melted away, the land is slowly coming up because when the ice sheets were there, it pressed down on the earth, and the rocks deep below the surface are kind of really hot and over long time periods kind of act like a fluid, so it kind of flows away from where the ice sheets were. And after the ice sheets melt away, those rocks sort of flow back to where that ice loading was. And as a result, after the ice melts away, the land slowly rises and you'll have raised beaches. And that was the example I gave around Hudson Bay. That is the mechanism for that. The second component of glacial isostatic adjustment that causes raised beaches is a process known as ocean siphoning. And this happens further away in what is known as the far field of the ice sheets. So in like tropical areas, for instance. And basically, what happens is because those rocks underneath where the ice sheets were are slowly flowing back, that actually causes the land to sink in the areas that were peripheral to those ice sheets. And because that's changing the Earth's shape and the gravitational field, that actually causes water from the equatorial areas to rush towards where the land is sinking. And as a result, in tropical areas, sea level was slowly dropping for the past 5,000 to 7,000 years. And that's, of course, starting to change now, and I will discuss that in the future, I'm sure. Another unrelated reason you'll have raised beaches are due to earthquakes and volcanoes. And this seems kind of obvious. If a big earthquake happens, it can cause the land to go up. And as a result, you'll have a raised beach if that happens along the coastline. A really great example of that is along the coast of Chile on the island of Isla Mocha. And Isla Mocha is a very rapidly uplifting place, and it's estimated there's been about 38 meters of uplift in the past 6,000 years. So if you look on Google Earth and look at this island, you can see a whole bunch of raised beaches there. Volcanoes can also cause raised beaches as the magma chamber inflates. This was actually observed in part by scientists in Italy, and that was reported in Principles of Geology by Charles Lyell, which I'll talk about in a minute. Another reason you might have raised beaches is a process known as dynamic topography. And this is less important for raised beaches in the past 100,000 or 200,000 years, but over longer time periods of millions of years, this is a more important process. So basically what dynamic topography is, the Earth's surface is slowly changing because the rocks deep below the surface are slowly flowing due to convection. So it's kind of like a lava lamp. So basically, you'll have the shape of the Earth sort of slowly changing because the rocks are sort of flowing. And in general, because of this process and erosional processes, you don't find really ancient raised beaches. But there is a major exception, and that's along the east coast of the United States. So along the Appalachians, there's a very long raised beach, and it's been investigated for at least a century, I think. So, yeah, it's been uplifted due to this dynamic topography process. If you go very long time periods, like the center of North America used to be a shallow sea during the Cretaceous, and now in some places that's been uplifted by over a kilometer, and that's again this dynamic topography process. So why would I call the podcast the Raised Beaches Podcast? Well, I studied glacial isostatic adjustment, which is responsible for two of the causes of raised beaches. So, of course, you can use those raised beaches as evidence of what the size of the ice sheets were based on, the elevation of the raised beaches as well as the age and how quickly the succession of raised beaches changes. You can use that information to infer the size of the ice sheets using modeling. So this was a very important component of my PhD thesis, and as a result, raised beaches kind of have a soft spot in my heart, and I still enjoy talking about them and studying them. So because raised beaches to me are so important, I thought, well, when were the first studies on raised beaches? When did that happen? So I went into Google Scholar and I typed in raised beaches and went back to the 1800s, and the first mention of the term raised beaches was found in the 5th edition of Charles Lyell's Principles of Geology, which is one of the fundamental treatises on the discipline of geology when geology was just starting off as a science. However, in Edwards and Craven, they stated that the term was probably first used in Ireland by Irish scientists, and indeed, Lyell was using this term raised beaches when referring to these studies by these Irish scientists. So I went back to these Irish studies, and yes, in the Journal of the Geological Society of Dublin, there were, in 1838, two studies which used the term raised beaches. One was by John Schuler and the other by Joshua Trimmer. Now, the study by Schuler doesn't actually use the term raised beaches within the text. It was just in the title of the journal to describe the paper. However, the second paper by Joshua Trimmer actually goes into detail about what is a raised beach and how it's defined and how it's related to the ocean. So this, to me, is the first true study on a true definition of what is a raised beach. So as I mentioned, the raised beaches were used in Charles Lyell's Principles of Geology as a piece of evidence for his theory on the fact that the Earth is changing. And this led to a noteworthy debate because Charles Lyell proposed that the Earth is changing, and some people didn't really agree with him. So this led to a really big controversy back in the 1830s. And this controversy goes back to a scientist named Maria Graham. And Maria Graham, she was an academic and journalist, and she happened to be in Chile during a major subduction thrust earthquake in 1822 called the Valparaiso earthquake. And Graham wrote a very detailed account of the impacts of that earthquake. So because of her very detailed account of this earthquake, it really caught the eye of the geologists in Britain at that time. And they asked her to publish her account in the Journal of the Geological Society. And after 200 years, I think most people probably don't know about this paper, but this paper was quite important for the then nascent discipline of geology. And one thing that was notable about Graham's paper is that it was the first paper published in the Journal of the Geological Society that was written by a woman. And at that time, women were not even allowed to be members of the Geological Society. And I think it really showed that she was very well respected as an academic at that time. So the details of this paper, she basically described that the earthquake caused about over 1 meter of uplift in Valparaiso, and that all along the coast, upwards of 100 miles or 160 kilometers from Valparaiso, there was a substantial amount of uplift. And she noted that the beach was no longer connected to sea level, that there had been the creation of a raised beach. And her quote was, and she actually went further inland and found evidence that there were more raised beaches at higher elevation. And she noted, I found good reason to believe that the coast had been raised by earthquakes at former periods in a similar manner. Several ancient lines of beach, consisting of shingle mixed with shells, extending in a parallel direction to shore to a height of 50 feet above the sea. So this was also proof that over time there had been many similar earthquakes that had uplifted the land. In the first edition of Charles Lyell's Principles of Geology, which was published in 1830, he used this as evidence that the mountain ranges were being created by large earthquakes, and this was one of his major hypotheses, that the world was changing. And this was not something that everybody agreed with. And one of the biggest detractors was a geologist named George Bellis Greenough. And so Greenough very much disagreed with the idea that the Earth's surface was changing in this kind of manner. So Greenough, he was mostly known as a compiler, and he produced a geological map of England and Wales in 1820, and later on a similar map in British India. And in some ways, reading his biography, it feels like he's kind of like an early 19th century version of me, like taking all the data and synthesizing it. But I like to think I'm a bit more open-minded than Greenough was at that time. So in 1834, Greenough was the president of the Geological Society, and he used his presidential address to criticize Lyell's hypothesis. However, he didn't directly attack Lyell. Instead, he attacked the credibility of Graham's account of the uplifted beach, the raised beach that was formed during the 1822 Valparaiso earthquake. And yeah, in a very indirect way, he basically accused Graham of lying. And in one account, he said, "Oh, she would have been too scared to have been able to write these detailed descriptions." And yeah, Graham was not happy about this, and by the time this happened, Graham had remarried, and her name was then Lady Calcott, and the account is that she was really angry about this, and her family was also angry, and we're going to like challenge Greenough to a duel. And she said, "No, don't do that. I can take care of myself." So anyway, her response to Greenough is very cutting and full of snark, and it's so great to read. It's really, you can really tell she does not think much of Greenough. And one of the quotes from this is, "Mr. Greenough says further in his address, some mussels and oysters still adhere, she says, to rocks on which they grew. But we know not the nature of these rocks, whether fixed or drifted. Mrs. Calcott was ignorant that there were or might have been drifted rocks until she learned it from Mr. Greenough. For much as she had been at sea, she had never met one." So if you don't know 19th century English, basically Greenough was saying that these rocks, which were composed of granite, could have drifted onto the raised beach through the ocean, and Graham basically very sarcastically said she'd never seen a floating rock on the ocean. So anyway, this response to Greenough was so thorough that the other geologists were like, "Yeah, Greenough really embarrassed himself by not carefully going over what Maria Graham had wrote in her paper." And Charles Lyell, he became the president of the Geological Society after Greenough's term was finished. So he had his own presidential address and said, well, I had no reason to doubt Maria Graham's observations. And later on, Captain Fitzroy of the Beagle also noted that in 1835 there was a similar earthquake in Chile that also uplifted the land. And later on in that year, he also noted that Charles Darwin had gone back to Valparaiso and confirmed Maria Graham's observations. So Charles Lyell said, I had no reason to ever doubt these observations, and Greenough, whatever. So yeah, that was a really interesting conflict that happened in the early days of geology. Of course, I would be remiss if I didn't talk about my own experiences with raised beaches. And, speaking of the voyage of the Beagle, my story of raised beaches were following in the footsteps of Charles Darwin in Patagonia in Argentina. In 2019, I went on a expedition led by Alessio Rovera, who's now at University of Venice, but at the time he was in University of Bremen. And basically, along the coast of Patagonia, there are a series of raised beaches all along the coast, and Charles Darwin was very fascinated by this because he measured the elevation of these beaches and terraces that are along the coast and found they're sort of at each terrace is sort of at the same elevation all along the coastline. And he also noted that the beaches at higher elevations tended to have fewer and fewer fossils that were similar to the present day fossils along the coast, or present day shells and that you find along the coast now. And he also compared the beaches on the Argentinian side versus the Chile side, and noted that these beach deposits are, generally speaking, not deformed or altered like the ones in Chile. And so he noted that there was a difference in the process behind what was creating these raised beaches. So one of the main places that we stopped in our journey in Patagonia and in Argentina was a village called Camarones, and our purpose on this trip was actually just to remeasure some of these raised beach and beach ridge landforms that had been surveyed in the past with less precise measurements. So we were hoping to narrow the range of what we know about past sea level. And so in Camarones, the raised beach and beach ridge deposits have been investigated by a PhD student, Carlo Rubio Sandoval, and the preprint of this is out, and hopefully the paper will also be out soon. So that'll be nice summary of what I'm about to say. So in Patagonia, there's several reasons why you have these raised beaches, and Darwin assumed that the land was uplifting because that's what was happening in Chile, and that was very clear that the land was uplifting in Chile. And for some of the really old beaches, that is the case. The land is uplifting not due to earthquakes, but rather due to dynamic topography. And the reason for most of these raised beaches is actually a few different things. The primary one is ocean siphoning. So basically, the water is getting sucked towards the northern hemisphere due to the rebound of the land after the ice sheets melted away. A second reason is that the continental shelf, like the offshore area of Patagonia, is really shallow, and basically you have the water loading on top of it, and it sort of acts as a lever a bit. So that can also affect the land motion, and that causes that's part of the reason why you have raised beaches there. And finally, you have to remember that in certain times in the past, the ice sheets in Greenland and Antarctica were smaller than present, and that is why some of these raised beaches are preserved as well as they are. So in Camerones, there are four raised beaches. The youngest and the lowest, of course, is the Holocene raised beach, which formed between 4,000 and 6,000 years ago, and basically it's these very long wavelengths, very very gravelly beach ridges, basically, and they indicate that in the past few thousand years, sea level was up to 6 meters higher than it is now, and it's been slowly dropping as a result of this ocean siphoning process. It's very clear to see that these Holocene beaches from the older ones, because there's no vegetation on them yet. The second youngest is deposited in the last interglacial between 115 and 130,000 years ago. And all along the coast of Patagonia, you find these raised beach deposits that date to this time period. And what's interesting is you go to these deposits, and some of them are kind of almost like rock now, but you find lots of shells in them, and the shells are in really nice shape. They're fully intact. And Carla determined that these deposits indicate that sea level was about 9 meters higher than present, so about 3 meters higher than it was about 6,000 years ago. The third beach ridge is higher than the last interglacial, and it was only preserved in one spot, and it was kind of in rough shape because it was being mined for gravel, and in fact, after 2019, it was completely gone. And but we did get some measurements there, and based on the age that we got from it, we don't know the precise age, but there are two possible time windows based on what we know about the history of glaciation in the past 500,000 years. So it either formed between 300 and 340,000 years ago, or between 370 and 420,000 years ago. And this deposit indicates that sea level was about 14 meters higher than present. So again, about 5 meters higher than the last interglacial. So we suspect that this deposit represents the time of the highest global average sea level in the past probably 2 to 3 million years. So it's a really interesting deposit, and it's too bad it's gone now, but what can you do? And finally, the highest elevation beach deposit is much older, and it was deposited in the Pliocene, and it was dated by Alessio to be about 5 million years old, and indicated sea level was about 28 meters higher than present. And this deposit probably formed at a time when the Greenland ice sheet was probably not there yet, and the Antarctic ice sheets were smaller than present. And even though this deposit is 5 million years old, you go to it and you just grab it, and it's just like, it doesn't seem that old. It's not lithified. You can grab the shell fossils out of it. And yeah, there are not very many places in the world with such a well-preserved beach deposit of that age. So I think the only other place where it is deposited like this, or preserved like this, is in South Africa. And so it was exciting to see this very unique deposit. If you go further south of Camerones, there are older raised beach deposits, and they've been uplifted because of dynamic topography processes. Some of them have been dated to the Miocene, so like 10 to 12 million years old. And anyway, the reason I know some of this is because I wrote a paper on this in 2021. It was fun. I got to compile all the previously published data. So you please check that out if you want to know more information. So in summary, raised beaches were one of the first major pieces of evidence that the surface of the Earth is changing, and provided some nice evidence for some of the early hypotheses of geology. And I use the raised beaches as evidence of past ice sheets, and I use them in my modeling, and I like to compile them, and I've been doing that for a few years now. And of course, raised beaches also continue to be important to know about to determine earthquake hazards. So places that are uplifting due to earthquakes, you can use this information to find out how big past earthquakes were. And of course, we also need to know about past sea level changes to assess future sea level, basically as a baseline. And anyway, that is raised beaches. And in future episodes, the deep dive probably won't be quite this long, but I felt it would be fun to really go into what a raised beach is, because I personally feel a lot of connection to it.